Thank you everyone for joining us today on the Cloud Native FM podcast. And if you are struggling to do a Kubernetes troubleshooting as of today, and this is episode for you. Today we have a guest, Natan, and he's a founder of Robusta.dev. He's an open source tool for the troubleshooting and automation. Thank you very much, Natan, for joining me today. Share, just try to introduce yourself to the audience first.
Hi, so I'm Natan. I'm the founder and CEO of Robusta.dev. For many years before that, I've been a developer. Got started with open source development in Python back when I was in high school. Been very active in open source communities ever since, and I guess the rest is history.
Yes, absolutely, absolutely. I was looking for today is like day one of learning Robusta and Kubernetes troubleshooting. Just before we just starting, tell us about your quick story, how you find the Kubernetes troubleshooting area as of today, and how you when you did even think about of making something an open source tool for the community in this Kubernetes troubleshooting area.
Yeah, so before I started Robusta, I worked at a startup in the Kubernetes security space, and there I just encountered these issues personally as a developer. So I ran on Kubernetes myself. I developed for Kubernetes. I happened to develop security software for Kubernetes, but really the software itself didn't matter. And for me, I came to that when, one, I was new to Kubernetes. I had a lot of software development experience, but no Kubernetes experience. And two, even after I had that experience with Kubernetes, then I saw there are a lot of things that really are hard, which I felt didn't have to be hard. One thing I like to say about Kubernetes is that Kubernetes makes the really hard stuff really easy, and it makes the easy stuff really hard. And what I mean by that is I can go and I can scale it up 1,000 copies of my application. I can run across multiple different nodes and different parts of the world. I can do all those scaling. I can do the most complicated things with like a configuration I can write in 5 minutes. But if I want to do something really simple, if I want to go and I want to troubleshoot, and I want to attach a profiler to a pod, I want to see what's taking up CPU usage, I want to see why something is leaking memory, or even if I just want to see why a pod is crashing, then either it's hard to do that stuff, or it's not hard to do, but it's annoying to do. And then combine that with why I started off by saying there's this big knowledge gap, and people like me a few years ago start using Kubernetes, and we don't have all that experience. And then you have an area that's really ripe for disruption, an area where on the one hand, there's this huge need. And on the other hand, there aren't that many good solutions, definitely not open source ones today.
Absolutely. Basically, I think it's an unexplored area for a very long time. We don't see a lot of the often tool in the Kubernetes troubleshooting landscape. But I think right now, Kubernetes companies and open source communities are investing heavily on that space, and that's a good news. So tell us about, just dive into the Robusta. Tell us about, feel free to share your screen and tell us about Robusta, what it does, and also tell us about what are the different patterns as of today exist in the Kubernetes troubleshooting landscape. Like one of the patterns is you have a sidecar is existing inside the Kubernetes, and then you troubleshoot those application development, application techniques, or application troubleshooting in that sidecar. A rest from that your application we're running on it. So what are how are the different patterns are available, and what are the different ways Robusta is using these patterns?
Yeah, excellent question. So there are really a few different approaches. So one approach is to gather all the data all the time, send it to the cloud approach. So that's an approach, for example, where you say, okay, I'm going to run profilers and everything all the time. I'm going to gather all my logs and send it to Elasticsearch, which is a good thing, and you should be doing that. Don't get me wrong. I'm going to gather all this telemetry. I'm going to gather all this data and open telemetry. I'm going to gather all that data and send that all the time to some server on the side. And then you have this huge amount of data collection, which is very good and very useful. But when an error occurs, then you now have a problem to go and sift through that data and to correlate stuff and to really understand why something happened and how the stuff is related. So you could have, for an example, you could have a Prometheus alert that's firing, that you have a crashing pod, but the logs for that aren't in Prometheus. Prometheus itself doesn't track the logs. So the logs for that are somewhere else. So the first thing that you want to see if you're a developer and a pod is crashing is, okay, where are the logs for that crashing pod? But you can't actually get that data from Prometheus itself. So the first approach here is you're gathering all the data, you're sending this all off to somewhere on the side. and you're doing this with like another system that's running in the cluster as a daemon set or something else. And then you have to, the burden is on you afterwards to take all that data and sift through it and correlate it and find the needle in the haystack. The second approach that we're seeing increasingly is to essentially say, okay, we're going to take one universal layer and we're going to drop it in different places between your application and between the outside world. So this could be a sidecar, for example. It could be that you're doing it with eBPF, but it's a similar concept. And you're essentially saying, I'm going to have one tool here that always sees everything. And that tool has full visibility into everything. And also there's other stuff here like Pixie Labs, which New Relic purchased, that's doing that with eBPF. And typically the downside of some of these solutions, especially sidecar-based solutions, is that you now have this extra overhead that's there all the time. You're running all of your traffic through this sidecar. And then that sidecar is always gathering data, if it's Istio or Envoy or whatever, or another service mesh, and sending it to some other location. And again, you have all this data, and this time it's a little bit more correlated because it's a little bit easier to gather. But still, you're gathering all this data, and then you're sending it off to the right place. We can then look through that later on. And then the third approach that we're taking here is, which we're taking with Robusta, is we're saying, okay, we don't care whether you're gathering it like using sidecars or agents that are running as daemon sets, or we don't care if you're just gathering everything and sending it all to one location. We're not going to solve that problem because all the data is there. Everything, it doesn't matter how you gather it, you can get the data in some way or another. But what we want to do is we want to help correlate that, and we want to help orchestrate it. We want to make it help happen at the same time. So to give an analogy for that, it's like Docker versus Kubernetes. Docker can run containers, but you still need an orchestrator to make those containers run in the right way at the right time. So what we're doing is we're sitting on top of like all the stuff of like type 1 that's getting gathered, and then we can pull in data when necessary from these other locations. And then there's something that we need to go even deeper, then on the fly, we can inject some extra troubleshooting agent or whatever and gather extra data on the go. But we're trying to do the orchestration for that.
Yes, absolutely, absolutely. That's a great way to think about it, because I think as you draw, like Kubernetes makes simple things more complex. Like it's really hard to able to understand because there is so many resources in Kubernetes. You have a deployment, the stateful set, the replica set, then you have an ingress controller, then you have CRDs, the custom resource definition that people have created. So there's so much things in it. And also the Kubernetes is sit on top of the cloud. Like might be it's running on the EKS, might be it's running on the Azure, might be running on the GKE. And in able to troubleshoot, we need to figure out, is it the cloud where my Kubernetes cluster is running? Is it the downtime? How well is it operating? Then you have application that run on top of the Kubernetes. And might they crashes as container come and go, they are ephemeral in nature. So I think there are 4 C's like we're talking about: the code, cloud, container, and cluster. And all these are the troubleshooting on some way or the other. And when you make some tool on top of it, it's really to be able to understand what the area you are talking about. Are you talking about just code? Are you talking about just clusters? Are you talking about the container? Or are you talking about the cloud? So the next question is for you. Like if we use Robusta, what are the targets? Which audience is Robusta is actually trying to, is attended for?
Yeah, okay, so today what we're focused on is not the underlying cloud infrastructure. What we're focused on, and we're not focused in general on the cluster itself, we're focused on the stuff running on that cluster. So you deploy an application, the application crashes, you want to get a notification of that. You can get a notification via Prometheus, you can get a notification directly via Robusta in your Slack channel, you can get it in different ways, but you want there to be extra data there. So it's not enough to just see it crash, you want to pull in the data on why. A node becomes unhealthy. The node it might become unhealthy, and you might discover that via Prometheus alert, you can discover it directly via Robusta itself without Prometheus. But whichever way you're doing that, whether it's Robusta alone or Robusta with Prometheus, when you see that the node is unhealthy, there's extra data that you have to see to investigate that. So Robusta is orchestrating that. It's pulling in, so when you get a notification in Slack, this node is unhealthy, then you get a notification saying, oh, here's what's now running on the node and what's impacted. Here are the resources that are currently being used on the node. So essentially, we're not focused on, when I say we're not focused on the cluster itself, what I mean by that is like we're not focused on that CD, we're not focused on, we look at nodes a little bit because you kind of have to, but we're not really focused on the underlying cloud infrastructure itself at the moment. What we're focused on is when something goes wrong, then just pulling in the right data from the right places to show you why it happened and how you can fix it. So to give a very specific example here, like let's say you have high CPU throttling. Now, I want to compare this just for a moment to the old world before Kubernetes. In the old world, if you had an application that had high CPU throttling, then in other words, you're not getting enough CPU. That's what it means. You're starved for CPU. So in the old world, before Kubernetes, before containers, you had an application and in your monitoring system, and the alert came up that it's not getting enough CPU. There was a really easy solution. You bought a new, bigger server. There wasn't anything to do with that. Just buy a bigger server with more CPUs. But when you now take an error like that, the same error, a very similar error for Kubernetes, then you have high CPU throttling, but what you do to fix that is now really complex. There's a decision tree. You have to ask yourself, is it high CPU throttling because I defined my CPU request wrong, my CPU limit wrong? Is it high CPU because I defined them right, but someone else is running on the node at the same time, and I didn't define things right for that, and that's stealing CPU from me? Is it happening because there aren't enough resources in the cluster altogether? Is it happening because of some other issue related to the way it's calculated with CFS on Linux kernel? Like there are various issues there. Debugging that and troubleshooting that simple case is no longer a simple, buy a bigger server with like more CPUs. In Kubernetes, you could put on a bigger node with more CPUs, but you might not even get scheduled to that node. So there are a lot more things going on then. In order to take a simple alert like high CPU, you have to run a decision tree on that. So what we're doing with Robusta is we're doing the orchestration, we pull in the relevant data, but we're also just running a Python function when that alert occurs, which analyzes it, and then just outputs to Stack the bottom line, what you have to know and how to fix it.
Absolutely, absolutely, and everybody who's listening to this podcast, I think that's really the key challenging factor. Like, use suggested a request for the Kubernetes YAML that your pod need this amount of RAM, this amount of CPU, and then you scheduling pod. How do you able to ensure that these pods are scheduled correctly, the CPU and the RAM is correctly mounted, and these are the really challenges. And when the application is like the drift, like it's the way you want it to be on the production is not as when you deploy it, and you want to fix those things, and you need to critically think about them. Previously, when you don't have these solution, you look at the kubectl get events. What are the events? What are the logs coming up? And you need to go deeper into it, and you get so much time into it. But it is going to be nice give you that information onto the Slack channel. Like, this is the data that we are pulling the information, because in the Slack you have invest more time into it. So that's a great way of thinking about solving the problem, is to able to understand the folks who are dealing with these troubleshooting tools. Everybody, if let's say I'm not in the team, and somebody else, like let's say I have a fever, I'm not able to be part of that team, somebody else look up those Slack notification and see what are the response, what are these errors are, and they can quickly fix those up. Like, as you mentioned, like you can give them a tips of how to make it not just there's a problem in the production, but this is the way you can fix the problem. That's another, I think, the great insight, because I love those tools that give you some hints, some pointers where you can how to do make things normal. So
Yeah,
tell us.
maybe I'll share my screen. Can I share my screen for a moment and show you this exact example, maybe?
Yes, absolutely.
Okay, so I'm just gonna share my screen. Okay, so
and meanwhile, you can learn, anybody who listening or watching with us, go to their home.robusta.dev. All the information is available. Also, we have a Slack channel dedicated for the team. And also, you can follow the robusta.dev on the Twitter handle that's mentioning. So we can ask question afterward if you have more questions.
Thank you very much.
No,
okay, so here's an example where I'm getting an alert saying CPU throttling high, processes experience elevated CPU throttling, right? So there's an explanation here which we're putting in. This pod is throttled, it wanted to use the CPU and was blocked due to its CPU limit. And then tip, and then you can open this up and read more, and then there's the recommendation on how to fix it. But what you have to keep in mind, and there are graphs here and other stuff, but what you have to keep in mind is that this recommendation is not static text. What happens is essentially what we're doing in Robusta is we're defining a mapping between each other and then between automated runbooks. So if I look at CPU throttling high, then CPU throttling high, we have here an automation. So I'm just going to zoom in on that. These are the Robusta automations that you get by default. So what we're defining here is that whenever there's an alert called CPU throttling high that comes from Prometheus, then you should do two things on this. One, you should grab a graph, and it grabs the relevant graph for that alert. And two, you should run essentially an automated runbook, an automated Robusta action called CPU throttling analysis enricher. It's a bit of a mouthful. If I go and search for this now in the code, then this is one of those Robusta automations. And if I just go back for a second, and I'm going to copy this message, this pod is throttled. You can see here, for example, there are multiple cases, and we're checking each case. And then for each case, we're telling you what to do. So this explanation right here, I believe, is this exact one. But if the pod didn't have a CPU limit, we would be giving you different advice. And if the pod was a metric server, which is a very specific thing, we'd be giving you even other advice, because in that case, there's nothing you can do about it. And if the pod was metric server, but it had a CPU limit, there are all these different cases. And for each case, we essentially just show you in Slack the exact right case. And what's nice about this is we're just taking what you would do in your head. We're taking the knowledge inside your head, and we're turning that into an automated Python function. It starts at line 4, and this Python function goes down into line 71. So it's one of our longer runbooks, actually. It's very simple, but it's one of the longer ones because we have a lot of different text and explanations in here. And we're essentially taking that knowledge that's inside your head, and then we're putting that knowledge now out into the world in an automated way that's shared between all the companies that use Robusta, where people can come and open a PR if there's a better way and if there's a different way that you can do it. And suddenly, what either you had to do and you had to know, and like your friend would call you up and say, oh, Natan, what do I do now when this alert happens? It just happens automatically via this Python function. So our goal ultimately is that for every single Prometheus alert in the world, we will provide coverage, and we will be able to tell you exactly what to do. And we will pull in the relevant data. Sometimes we won't be able to do something super intelligent, so we're just pulling the logs, or we're pulling the right Prometheus events, the right Kubernetes events. And we will do all of that. And then we will be able to show you the exact data that you need at that exact time. We will constantly grow our coverage. And that is really the first part and the first major use case for Robusta.
Absolutely, that's a great details, and I think that these are the missing point we currently have. Also, another question, like let's say we have so many tools in the CNCF landscape, we have other tools that gives you some remediation on the fly, like if something bad happened, let's say 2 a.m. while you're sleeping, and some of the things down and outages come up in the cloud, either the application crashes. And there are some tools available in the market that give you some remediation things. Like one of the projects called Captain Project that give you that remediation. So can you point us, like if somebody is using those tools, how they can integrate Robusta with that stack, that's cloud native stack, and then you can do so many amazing things with it. And just share your learning experience so far.
Yeah, I would love to. So I'll give two different answers here. So the first answer, I'm just going to go back and share my screen again. The first answer is you just add on your own function like this. You build them into Robusta as a plugin. So I could write define do my remediation. And this takes, let's say, a pod as input, if this happened on a pod. And then over here, I just put on that decorator, that action. And now I would run subprocess.run, and I would just do something that communicates with that external tool. And if you're doing it, we actually would have to only add on a function like this once for, let's say, Captain. You add it on once for each external tool that you're integrating with. So I can give you an example. It's not quite an auto remediation. Well, it kind of touches a little bit on the auto remediation. If I go to our docs today, let me just show that over here. So I can search here for Argo CD. So here's an example of an Argo CD sync where from Robusta, you can trigger something that will do a sync in Argo CD. And to configure that, then you just have an action here called Argo CD sync or Argo app sync. So that's one way. We can really easily integrate with these, and either we have something ready in our collection of automated actions, or you automate it yourself and you just add it, open a PR, or you put in your own private action repository. The second answer is we're also building capabilities like that into Robusta itself. So here's an example of that. I don't have a live demo of this set up. I just didn't set it up in advance. So I'm looking at the screenshot. But let's say you reach the maximum number of HBAs, then Robusta can send you a message in Slack saying, okay, well, upgrade, do you want to update the number of max replicas by 30%? And then you just click a button and it activates that. And that's essentially using the same framework over here. That's an automated action. It's just asking you for confirmation in between, in the middle. I hope that helped answer the question.
Yes, absolutely, absolutely. That's a lot. That's a wonderful. I think one of the things that it's already integrating with existing tools, plus it's providing the information for you to remediate yourself. Like, it's a wonderful way. Like, if you see the Slack notification that you have least amount of nodes or pods available and you need to increase it, you just click on the button and it's automatically updates you. That's a great way to think about it. It's like a heavens for the people who are having trouble with doing the deployment and making the production system up to date with it. So I think that's a wonderful analogy. And also tell us about what is actually currently in the plan and how you look at them. What are the common, let's say, the use case scenarios, or what are the suggestion or recommendation, or the people reaching out to you tell you, we want these things to be have in the Robusta. We want this thing to have in the Robusta. And also people who are using the EKS, GKE, or Azure Kubernetes service. Tell us about how those people can use Robusta.
Yeah, so for the most part, we don't care what cloud platform you're running on. Whether you're on, and I should just do a call out to Civil Cloud. They don't sponsor me or anything, but I'm a huge Civil Cloud fan. Used it yesterday for a demo I did with Microsoft Reactor. I really like Civil Cloud. We actually have one specific robust issue we have to fix there because they're taking a port that we need in advance. But you just call out to Civil Cloud as well. Excellent platform. And again, I won't get paid anything. I'm not sponsored. But for the most part, we don't care which platform you're using. It doesn't matter to us. We'll support all the different platforms. And then what we see is a lot of people install us on like day one. Like, you just set up your cluster, you need the monitoring stack. So instead of setting up Prometheus alone, you can set up Robusta, and it includes, there's just a Helm chart option, includes within it in the same installation, includes Prometheus, includes Grafana, it includes everything you need, and you'll get up and running with one package. And we're just using the upstream stuff. So we're using the other stuff by integrating it with us. And then you get an out-of-the-box monitoring stack. And that's one thing that we see a lot of people doing. And then kind of on day two, we get a lot of requests from people who are saying, okay, I'm running Go applications. So you have stuff like to help you troubleshoot Python applications. Can you add on support for Go as well? So we get a lot of requests like that. And a lot of those requests are around not the automated stuff that will show up in Slack automatically, but there are also automations that you can trigger yourself. Like if there's a Python application that's running, you want to see, okay, why is that using high CPU? Like, there was no other, but you see it and you say, okay, like right now, tell me what its CPU is doing. Or there's a Java application, you say, right now, give me a memory dump, or tell me where the biggest objects in that Java application's code. Or tell me right now, give me a stack dump from that Java application. Those are all things that we can do today. And typically those are automations where you push a button to make it happen. So for those automations that you kick off yourself by pushing a button for troubleshooting applications, we get a whole lot of requests today to add on support for different languages.
Yes, absolutely. And also on top of that question, like, let's say somebody's configuring a CI/CD pipeline or GitOps pipeline, and they want to configure Robusta as part of their CI/CD or GitOps pipelining. Is this functionality is available as of today?
Yeah, great question. So you actually don't have to do anything. It'll just work. Can I share my screen for a second and show another example of that?
Yes, absolutely.
So before I start the screen share, I'll just explain what I'm about to show. What we do today is when you install Robusta once on your cluster, and then everything that happens to your cluster, we will just pick up and track. And you don't need to do any configuration per application or per CI/CD pipeline. Now, one big part of troubleshooting, and again, this is just about pulling in the right data at the right time. If an application crashes, here's an analogy I like to give, okay? You plug in, you buy some new electric blender, and you plug into the wall, and all the electricity in your house goes out. So there's probably a connection between those two things. But imagine now that like strangers are constantly coming into your house and plugging in different electric things, and then suddenly like the lights go out, you want to know who just plugged something in. And you should probably get a battery door and lock so that strangers can't come into your house. So when an error occurs in a Kubernetes cluster, you really want to know who just deployed something and who did something right before. So all the data is there, it's all accessible, but if you don't have access to the right data at the right time, then it's not very useful. So one thing that we do in Robusta is we can track the different changes to the cluster as well. And then we can pull in those changes and show them to you at the exact right place at the exact right time when an alert fires. So there are different variations on that. You can set it up so you get notifications in Slack with that. I'm just actually going to show that in our UI, which is a SaaS platform, but we actually have an on-prem version of that now as well. I will say that's the one component of Robusta that, at least today, is not open source. But heavy free tier, and please go and use it. And I don't want pricing to really be an issue for anyone. So let me share my screen and let me show you what that looks like. So if I go over here, I can see here all the microservices running in my cluster. Let me just go back a bit in time. And let's say I choose one specific microservice, so metric server. So I can see all the different issues that happened here and when they happened. But I can also see all the different changes that happened. So I can look over here, see that over here, someone changed this YAML and they changed this. And in this case, that was changed on March 13th. And the error that occurred happened on March 17th. So there's no connection between the two. But sometimes you will see an error, a change. And right after that change, you will see a whole bunch of errors that start occurring. And then again, it's like the house where someone plugged in the electricity. Like, you know, there's a connection. Like I can show you right here. This change that someone did here. As soon as that happened, there was a whole bunch of errors that occurred afterwards. So clearly these two are related. I can see that right away in this one too. These errors that occurred, they're almost certainly related to this change that was made. So we can also show that if you're just using the open source parts, we can also show that in Slack, and we can pull that data in different ways. And it's really about, correlating the data. The data is all there. You just have to pull in the right data at the right time.
Absolutely. I think that's a wonderful information that you just showed on the dashboard. Like, what if you just deploy something and you need to understand, is this change is causing some outages or some kind of bad vulnerabilities in the code? Like, it's just see all these data on the dashboard, and you can track those changes, and you can see, like, previously on that day, when I integrate my Git commit onto it and deploy the code, it happens widely to the whole cluster, the whole application goes down. So I think that's another. I think there's most of the use cases already familiar with it. But before I let you go, just the final question on this side, like, if people are using the CRDs pattern, the Kubernetes resource definitions, and they made their own controller into the Kubernetes, and these controllers are part of the application in itself, because a lot of the application deployed via the CRDs. And if something to the CRD, how you look at this CRDs troubleshooting area, plus how Robusta help with that?
It's just another Kubernetes type. I can run kubectl get pods. I can run kubectl get Prometheus rule, which is a CRD. So what we have to do in Robusta, and I'm saying have to because I'll explain what we do today, but we have to just track those like everything else. And we have to let you troubleshoot and do all the same things for those that you'd be able to do for everything else. Today, we do not allow tracking CRDs. Something that's on our roadmap to fix. So if you want to see, for example, on that timeline, the changes to CRDs, we don't do that today. But if you come to me and you have, like, you say, I'm using this CRD in production and I'm already using Robusta, and just give me this, like, we'll know to bump up the priority on that. And I just like to really reach out to people who are using Robusta. Oftentimes we find out by accident about people who are using Robusta or have even been using it for a month or two. So if you're using Robusta in a company with over 100 people, and I mean, there are at least 100 people in your company in total, not necessarily DevOps. We would love to talk to you. It's really important for us to hear from people using Robusta in the bigger companies. and to really understand how they're using it. So please reach out to us. We'd love to talk to you. We'd love to give you free swag as well. And don't forget, by the way, I don't know if I already sent you swag or not, but I'd love to send something your way as well, and to anyone else who's watching. So please reach out to us, and it really helps us make this platform better for everyone.
Absolutely, absolutely. Yeah, this is wonderful. I think there are so many things I really like about this tool. Like one of the things I like, you go into the Slack channel and you just see just to see the random notification alerts coming your way, and you need to go to fix yourself up. And there are tools not give you some kind of freedom or liberty to fix those things it's just clicking the button of the Slack channel, and that is already available. Like one of the demo you should just show, you go to there are events coming up in the Slack channel, and you see there are right now when the CPU, my pod has need to have more nodes in it, and you just deploy the HPA and it's everything happen under the hood. That's automation. You can configure via pipeline or these kind of CRD is also on the roadmap. So I think there's so many great things about this tool as well. And you have your own YouTube channel, Robusta.dev YouTube channel. I think the link is available in the chat if you want to go. There are some videos that Natan has developed for all you guys, how Robusta can help you with that. But it's a great way of thinking about it. As anybody who's listening to us or watching us today, follow Robusta.dev and follow Natan on the Twitter handle. It's been really an ask question live during the way. And if you're there are some wonderful articles written by the Learn Gates team on the Kubernetes troubleshooting deployment. I think to go explore those absolutely, because these are the wonderful diagram we tell you about these things, and you by exploring those blogs, you can check how Robusta can solve some of those challenges, and this help you like how much the problem Robusta solve for you. So I think these articles, these blogs are really really for you. So thank you very much, Natan. We won't give you much time. You have a very busy schedule the whole day and talking about people at Kubernetes.
Yeah.
We hope to see you again in the future. Last question: do you go to KubeCon if everybody wants to catch up with you during the KubeCon?
I actually haven't bought the tickets yet. I really like to, and I know I have to be there. We were a little bit behind schedule on different things, but yeah, we're in the process.
Yes, absolutely. Thank you, Natan. It's been wonderful talking to you today. Day one of learning Robusta, and learned a lot of cool things about it. Hope to see you again in the future. Stay safe, stay healthy. Bye, everyone. Bye.
Thank you very much. Bye.